So hello dear students, welcome again to your chemistry the YouTube channel. So today I am going to discuss on a very important question asked in JEE Advanced 2024. Is a basically question is MSQ question. MSQ means multiple selective questions, means one or more than one answer may be correct. So this question is asking from the reagents chemistry. Normally we have studied this reagent chemistry in the class 12, like carbonyl chemistry, in this carbonyl chemistry part, right? So you can see there is a big molecule is there and it need to convert to this product. So the question is which reagent we can use. There are several reagents is asking in the different options. The first reagent is telling is linear catalyst. What the reagent is? Linear catalyst with hydrogen. And the second reagent is SnCl2HCl, third is NaBH4 and the fourth is H2O+. So first we need to understand the reagent purpose. If you know the reagent purpose, then you can solve this problem easily. It's not a tough problem. Okay. So what linear catalyst can do? It can do the conversion of alkyne to cis alkene, right? And the SnCl2HCl, normally when we look SnCl2HCl, we remember the Stefan's reactions, right? But the Stefan's reaction we need also water, but there is no water is given. Like after the SnCl2HCl, you can see there is NaBH4 is given, not water. So you can see this Cn is converted to CHO, means Stefan's reaction maybe happen here, right? But SnCl2HCl cannot convert Cn to CHO. So this option is eliminated. So first we need to eliminate the options, then we can solve this problem easily. So why I eliminated this options? Because there is only SnCl2HCl is given, no water is given. Then I will come back to again linear catalyst, NaBH4 H2O+ part. But first I need to just understand how can I convert this Cn to CHO. Okay, Cn to CHO means Stefan's reaction, right? In the second options you can see same means linear catalyst is also given, then water given in the first, and then SnCl2HCl is given. So we can't get Cn to CHO by this type of reagent because first water cannot move to Cn to CHO. First we need to understand SnCl2HCl purpose. What SnCl2HCl actually do? SnCl2HCl C triple bond N convert to this type of imine linkage, right? This type of imine linkage. And when you use this H2O, it basically converted to CHO. It basically converted to CHO functional group. Okay, this is the basically mechanism. So first water cannot get to Cn to CHO. First we need to put SnCl2HCl, then water. But there is first water is given, then SnCl2HCl. So this option is also eliminated because it cannot convert Cn to CHO, this type of process. But if you see this option C and D, you can see stannous-chloride hydrochloric acid is given first, then H3O+. Again option D, stannous-chloride hydrochloric acid given first, then H3O+. That means these two options may be correct for Cn to CHO process. So you may ask like there is no water, only H3O+. H3O+ means there is water is also there and acid is also there. So basically this is the basically to do the purpose of hydrolysis step. So this is a one type of hydrolysis also, like water basically get hydrolysis to carbon double bond N break and CHO is forming. So now basically in the H3O+, you know the water is there and also H+ is there. So this reagent, combining this reagent, we can get Cn to CHO because in H3O+ water is there. Stefan's reagent means what does it mean? Stannous-chloride hydrochloric acid first, then we use H2O. So there is there, you can see. And we can also see then first SnCl2HCl is given, then H3O+. So we can use this reagent 3 and 4, 2 and 3, we can easily convert Cn to CHO. So now the purpose is, what is the purpose of sodium borohydride, and lastly linear catalyst. So basically NaBH4 what can do? NaBH4 basically do carbonyl to alcohol. Carbonyl means this carbonyl. Why? Because NaBH4 can only reduce ketone and aldehyde. So these are basically ketone functional group. So it can reduce ketone to alcohol, sodium borohydrate we can use. Okay. And then stannous chloride HCl H3O plus CN2CHO. So maybe C option is correct. And lastly also H3O plus means H3O plus can use as a hydrolysis reagent. So what is the hydrolysis here? This ester get hydrolyzed to acid by H3O plus. If you use this H3O plus, it can also CN2CHO converted and also ester to hydrolysis, and not only these two, and also these ester. Also these ester can be hydrolyzed by this H3O plus reagent. How can I hydrolyze this ester? See, this is the acyl bond, and when H3O plus normally use, this acyl bond is normally breaking, and this right part remains as alcohol. See, this is alcohol part, and this left part fragment which goes out by carboxylic acid fragment. So basically this H3O plus is very important reagent here. It can convert to CN to CHO, remaining part COOET to COOH, and this ester part to alcohol. And when you use this last linear catalyst, basically it can reduce this alkyne to cis alkene. Why this is C? There is a hydrogen is cis there, and these two big alkyl group is cis position. So alkyne is converted to cis alkene. So option C is obviously correct answer for this transformation. Now option D. Option D first, if you use this linear catalyst hydrogen, it can reduce alkyne to alkene, cis alkene. So okay, this is correct. If you use this sodium borohydrate, it can also reduce to this carbonyl to alcohol. Okay, this is also correct. No problem is there. But when you use this SnCl to HCl with H3O plus, SnCl to HCl first converts Cn to this type of imine linkage. And when you use this H3O plus means what I told before. H3O plus means water and acid is there. So water basically hydrolyze this imine linkage and convert it to Cn to CHO, and also this H3O plus also converts this ester to acid and this ester to alcohol, because this ester basically breakdowns by this acyl bond. So remaining part as alcohol and remaining part is carboxylic acid goes out. So this type of reagent also option D is also correct. So I hope you understand this point as a very important